Hello, I hope you're ready for some more math. Couple problems for you today. Hopefully it's not too tough. First one is write a fact family for this array. So figure out how many doggies you have and write my fact family for me. The second one is I have a word problem about Keegan today. On Monday, Keegan ordered a large pizza with mushrooms, sausage, and anchovies. He had the pizza cut into 8 pieces and he ate 6 of them. On Tuesday, he ordered a large pizza with sausage and extra cheese. This pizza was cut into 4 equal slices and he ate 3 of them. On which day did Keegan eat the most pizza? Draw a picture to help. And remember, pizzas do not have to be round. You can make your pizzas rectangles. So go ahead and work on those problems and come back and check with me once you're done. Okay, when I did this problem, I noticed that I had 3 rows and I had 9 columns. So my fact family is going to be 3 times 9 equals odd, better have an odd answer, 27, or 9 times 3 equals 27, or 27 divided by 9 equals 3, or 27 divided by 3 equals 9. So hopefully you have that fact family. Let's try our friend that was eating pizza. Remember, I told you that I like to draw my pizzas as rectangles just because it's easier to compare them. And I like to compare things. I like to put them right up and down on top of each other. Okay. As I read, I noticed that Keegan ordered a large pizza with mushrooms, sausage, and anchovies. He had the pizza cut into 8 pieces, and he ate 6 of them. On Tuesday, he ordered a large pizza with sausage and extra cheese. This pizza was cut into 4 slices, and he ate 3 of them. On which day did he eat the most pizza? So I'm going to do a Monday pizza and a Tuesday pizza. And I'm going to do the Tuesday one first because I know it's easier to do 4 equal pieces. To do 4 equal pieces, I'm going to cut my pizza into half. I'm going to cut each one of the halves in half. Now, I know something. If I can take these same measurements up there, I can cut that pizza into 4ths right away. So I'm going to cut that into halves and cut each of my halves in half. And then I just have to cut each of those halves in half. Okay. So on Monday, he ate 6 pieces. 1, 2, 3, 4, 5, 6. Let's just making sure the camera is ready, running. And on Tuesday, he ate 3 pieces. So this was 6/8. This is 3/4. And did you notice something? That he ate the exact same amount of pizza. Because 6/8 and 3/4 are equivalent fractions. I'm still not sure about those anchovies. Okay, let's do a couple more problems and then we'll get going on our lesson for the day. In the first part of this problem, you guys already know how to do this. So if my green line's equal to 10 and my red lines are equal to 1, how would I write an equation for this and then solve it? So if I'm writing my equation, I know that I have 10, 20, 30, 3 times 1, 2, 3, 4, 5. Now I know on 33 times 5, my answer is going to end in a 5 because I have an odd times an odd. And whenever I multiply 5 by an odd, my answer is going to end in 5. Okay, so I'm going to go ahead and do this first part. I have 1, 2, 3, 4, 5 groups of 10. 5 groups of 10 are 50. 5 more groups of 10 are 50 more. 5 more groups of 10 are 50 more. Now I have three groups of 5, and 3 times 5 is 15. So I have 50, 100, 150, 165 is going to be my answer. The answer to a multiplication problem is always the product. So my product of 33 times 5 is 165. Now, I tried to fool you by making this next problem a little bit more difficult. So let's see if you can solve it. You notice that I have a group of 10s going down the side too. So I'm going to, why don't you shut it down, figure out what the answer is, and come back and check with me. Okay. When I did this problem, I noticed I have 1022 times 11. On this one, I'm multiplying an even number by an odd number, so I know my answer has to be even. And this isn't too bad. I can know that 10 tens are going to be 100. 10 more tens are 100 again. That 0 looks kind of silly. And 2 tens are going to be 20. Now down here, I have one more group of 10. And I have one more group of 10. And I have 2 groups of 1. So my answer is going to be 100, 220, 230, 240, 242. So the answer to that problem, the product of that is 242. Did you get the right answer? Here we go. Okay, I'm going to try to be nice to you today. Why don't you grab your yellow book and turn to page 251, and I'm going to do that page with you. So pause your computer a second, grab your workbook, and let's do this together. Okay, for this problem, the first question is, my team is dividing the pizzas evenly between blank people. Pick a number. You can pick 2, 4, or 6. Choose one of those numbers. Whichever number you pick, you're going to use to figure out your problems. All right. So I'm going to say I'm dividing it equally amongst 4 people. Again, you can pick 2 or 6. It all depends on what you want to do. Now, I told you a little earlier that if I do pizza problems, I always want to do rectangles instead of circles, because it's just easier to divide a circle than it is, or to divide a rectangle than it's a circle. Let's say that I would have picked 3. I can divide this into thirds real easily. A circle, thirds are, I'm not sure if that's exactly equal. So I'm going to get rid of the circle and just do rectangles. Okay, let's see if I can get rid of this and delete that. Okay, and here's our first question. It said, what happens when kids share 2 pizzas? So I took 4 kids, and I'm going to take 2 pizzas, and I'm going to have to cut my pizza into fourths. If you picked 2, you're going to cut your pizzas into halves. If you picked 6, you're going to cut your pizzas into sixths. So I'm going to cut mine into fourths. You cut yours whatever you picked. Hopefully my fourths are equal. And each kid gets an equal amount of a pizza. So I get this much of this pizza, and I get this much of this pizza. How much pizza did each kid get? Of this pizza, I got 1/4. Of this pizza, I got 1/4. So the total amount of pizza that I got was 2 pieces out of each one, and that's 1/4 of each of the pizzas. Okay? You figure out what you have for your number. Okay, The next problem is you're going to use 3 pizzas this time. So go ahead and do the same thing. You're going to use the same number of people. So if you used 2 people last time, use 2. If you used 4, use 4. If you used 6, use 6. And figure out how many pieces of pizza each person got. So I'm going to cut mine into fourths again. And I'm going to get 1 piece out of each of them. So I got 3 pieces of pizza out of that. Okay. Next problem is going to be the same thing, but you have to figure it out of 4 pieces. Okay. So go ahead and do that page. And your assignment for today is to do page 252 on your own. Take a picture of 252 and send that to your teacher. 251 you don't have to send it. So have a lovely day. Anybody who wants to stay in and do some enrichment with me, get your pencil and piece of paper ready. Okay, all you enrichment people, you might know that these are all angles. And we have 3 different types of angles. I know one's acute, one's obtuse, and one's supposed to be a right angle. It looks like that line's drooping a little bit. So it's actually probably not a right angle. It probably is actually a little bit of an obtuse angle also. I would like to know if you can figure out how many degrees of angle there are in each one of these. The way I like to do that is, I know if I draw a line straight up from there, I know that angle is 90 degrees. And about how much of a 90-degree angle is this? This looks to me, if it were half, it would be 45 degrees. It looks a little bit more. I would say this one is probably about 50 degrees. And I probably have about 40 degrees left over there. Now this one, I'm going to do the same thing. I'm going to try to draw a line straight up. Make that 90 degrees. So this one's bigger than 90, and I would guess that's probably maybe about 96 degrees of an angle. Okay. Next one. This looks maybe like about 91 degrees. Because this line, if I were to go straight out here, probably be just a little bit higher than that line. Okay. Now you know a little bit about angles and a little bit about degrees of an angle. I have a question for you. This is an angle. How many degrees are in this angle? Thinking? You're going to say, Mr. Gobler, that's just a straight line. It's not an angle. But actually a straight line is an angle. And if I want to prove how many degrees there are, I'm going to do the same thing I just did. I'm going to draw a line straight up. And I know this is 90 degrees on this side. I know this side would be 90 degrees. So I know every straight line is 180 degrees of angle. Remember that. You need to know it for your next part. So, oops, I missed something. Okay. So now if you remember, that straight line was 180 degrees. This is 55 degrees. Do you know how many degrees that side is? Think about it for a couple seconds, and then come back and check with me. Okay. I know that straight line is 180 degrees. So I'm going to take 180, and I'm going to take 55 degrees away from that. So 180 minus 55, 180 minus 50 is 130. Take away 5 more is 125 degrees. Now let's see if I'm right. I'm going to take out a trusty tool here. Let's see if I can measure that angle. This is called a protractor, and protractors are made to measure angles. And when I measure this angle, I put the dot right here where they meet, and I go up here, and it says 125 degrees. It's halfway between 130 and 120. Now, some people might say, Mr. Gobler, it's halfway between 50 and 60. But I know this angle's obtuse angle, so I know it has to be bigger than 90, so I'm going to use the top. Okay, let's try another one of these. Let's say this angle is 38 degrees. How much angle do I have left? Figure that out for me real quickly, will you? Okay, so I'm going to take 180 minus 38 equals. Now, in my head, I'm going to do this math real different. Instead of doing standard algorithm 180 minus 38 and doing some borrowing, I'm just going to take away 40. So 180 minus 40 is 140. And then I have to give back 2 more because I took away too much. So I'm going to get 142 degrees of angle. Okay. I'm going to do something really hard on you this time. Try to figure out these 3 angles that are missing. Pause your computer, figure it out, and see if you can get it. I know trying to bite off all 3 of these angles at once are going to be too hard. So I'm going to do something. I'm going to just look at this straight line. And on this straight line, I know that this much is 31 degrees. So if I want to find out this much, I'm going to take 180 minus 31. So this time I'm going to take away 30. That's 150. And take away 1 more. This is going to be 149 degrees. Now, I'm going to use this straight line. I know this much is 149. How much more is this? Well, 180 minus 149. Guess what? It's going to be 31 degrees. Now, if I use this line again, 31 plus 149 equals 180. So once you found out that that straight line is 180 degrees, you can find out all these other angles that you didn't know. I think it's kind of cool to play with this kind of stuff. All right. I'll throw a problem up for you. You get to do it any way you want. Now, before you do it, I decided to get an estimation for this. So I rounded 87 to 90, and I rounded 43 to 40. And I know if I do 9 times 4, I get 36. And I have 2 zeros as placeholders. So when you do your answer, you better be close to 3,600. So you go ahead and work on it, see what you get, and then come back and check me out when you're done. So let's do this together. I set it up 2 different ways. The 4th grade teachers told me that the best thing you can do is know more than one way to do your answers. Some of you guys love standard algorithm. They think that's a great way to do it, but they love it when you can do it other ways also. So let's do area model first. 8 times 4 is 32. I have to tack on those 2 zeros as placeholders. 7 times 4 is double, 28. I still have 1 0 to tack on. 3 times 8 is 24. Tack on that 0. And 3 times 7 is 21. Now, some of these numbers I might add together before I write them over here. So I can do 3,200 and 280 is 3,480. I know that 240 and 21 is 261. I can just add those together. And hopefully that's the answer you got. Hopefully I'm right. I'm going to do this problem to check it. Oh, am I close to my estimate? I'm kind of close. I might be there. So when I do standard algorithm, I'm going to forget about that 4 and multiply by the 3. 3 times 7 is 21. 3 times 8 is 24. And 2 is 26. Now, I have multiplying by a 10, so I have to put down Waldo. I'm going to keep nice straight lines when I do this. 4 times 7 is 28. I'm going to put down an 8. I've used that 2. I'm going to put the 2 on carry up there. 4 times 8 is 32, plus 2 is 34. When I add, I get 3,741. Same answer. Good. Here we go. Try another one. This time, I want you to do 74 times 22. And I did an estimate for you again. I rounded this down to 70, and I rounded this down to 20. So 7 times 2 is 14. Tack on my 2 zeros. Now I know my estimation is going to be a little bit low because I rounded both numbers down. So your answer better be a little bit higher than 1,400. You go ahead and try it and come back and check with me. Okay, this time I decided to do it standard algorithm and a ratio table. Ratio table. First thing I'm going to do, I have to multiply by 22. So I'm going to do 2 74s. 74 and 74 is 148. Now, if I'm multiplying by 20, I'm just going to take that 148 and tack on a 0. So it's going to be 1480. Because if I multiply 74 times 2, it's going to give me 148. Tack on that 0 for a placeholder. Now, this gives me 22 together, so I just have to add those together. So I'm going to get 8, 2, carry a 1, 6. I have 1,628, or 1,628. Now I'll do standard algorithm to see if I get the same answer. I told you it was going to be higher than my estimation, and I'm in the ballpark, so I think I might be good. I'm going to forget about that second 2. 2 times 4 is 8. 2 times 7 is 14. I Waldo, keep my columns. 4 times 4 is 16. Put down my 1s, carry my 10s. 2 times 7 is 14, plus 1 is 15. Add these together, I made a mistake somewhere. Freeze it, let me figure out what I just did wrong. For some reason, I did something goofy. I'm going to put down my Waldo again. 2 times 4 is 8. I don't know why I carried something. I'm going to cross that off. 2 times that is 14. I have no idea what I just did before, but it was sure silly. See, even old people make mistakes sometimes. And I got the same answer. Sorry about the error earlier. Let's try one more. You go ahead and do this one your favorite way, and come back and check with me. Okay. This problem, I decided just to do this one standard algorithm. Once I get into 3-digit numbers, I don't love doing area model. So I like to go to standard algorithm for this one. We're going to forget about that 3. 6 times 5 is 30. I'm going to put down my 1s, carry my 10s. 5 times 4 is 20, plus 3 is 23. 5 times 3 is 15, plus 2 is 17. Do you notice I'm slowing down a little bit this time so I don't make a mistake again? Now I'm going to multiply by my 3, but my 3 is actually a 30, so I have to put Waldo down in my 1 spot. 3 times 6 is 18. I'm going to put down my 8. Cross that 3 off, carry a 1. 3 times 4 is 12. Plus 1 is 13. Put down my 3, carry my 1. 3 times 3 is 9. Plus 1 is 10. If I add those together, I get 12,110. Is that what you got? I hope so. Let's try one last problem for enrichment today. And it is 346 divided by 14. I will let you work on it, and then I'll do it a couple ways for you. So first way we'll do it is doing a ratio table. And I kind of like to do my ratio tables the same, pretty much the same way I do my standard algorithm. I'm going to say I'm going to do a multiplication problem, but I want to know how many 14s go into 3. and I know it's 0. How many 14s go into 34? 2 14s are 28, so it's just 2. And I'm covering out one number, so I'm going to multiply by 20. And 20 times 14, 2 times 14 is 280, or is 28, tack on a 0 is 280. So I'm going to take 280 away from here. You get 6. So I have 66 left. How many 14s in 66? Well, let's see. I know that 2 are going to give me 28. And if I double 28, I get 56. So I'm going to do 4. And 4 are going to give me 56. If I take 56 away from that, I have 10 left. I'm all done. I have 24, the remainder of 10. Or 24 and 10 14ths. Or 24, I can divide both of those by 2, and 5 7ths. Now, let's see if I get the same answer over here. Standard algorithm. I'm going to say, how many 14s in 3? 0. How many 14s in 34? That is 2. That's going to give me 28. If I subtract, I get 6. 6 is smaller than 14. I can bring down my 6. How many 14s in 66? 14, let's see, times 4 is 60. 140, that's 56. So it's going to be 4. I can multiply, subtract by 56 and get 10. 10 smaller than 14. Now this is what a calculator would do. It would tack on another 0 and put down a decimal point and bring that down and say, how many 14s are there in 100? I can do 14 times, I know 14 times 4 is 56, so I'm going to try, let's try 7. 14 times 7 is 28. 2, 7, 98. So I'm going to put a 7 there and subtract 98. And get a 2. Magic, it was there already. I did the problem ones already. So I would get 24.7. And I still have a little remainder. I'll just throw that away. So all of these answers are right for that division problem. Hopefully that's the same answer you got. Hopefully you enjoyed doing some enrichment math today. Challenge yourself. Remember, math isn't scary. Have a great day. Goodbye.